Hello, Miss. Good afternoon. My name is Fadi Boulos. I'm going to be recording myself doing the assignment, the graded assignment. I'm in N3 class and my student number is 158. I'm going to be going to the exercise. Now, regarding the exercise, you have given us two choices. Whether we film ourselves doing the whole concept or the whole thing, or or we solve the exercise and then we film ourselves explaining every single aspect or how we obtained the numbers. I did both because I really wanted to explain every single detail. I'm really aiming for a good grade, and at the same time leaving some space for you to show you that I'm comfortable using Excel. Now let's start with the exercise. As you can see, I have kind of prepared or started with the exercise, but before I approach the exercise, I wanted to make sure that I deliver what is important. Now, when we started studying, it's important that I explain what's the main purpose of data analytics, what is data analytics, and in general, what are we seeing now? Now, data analytics is something that we study in order for us to make further decisions. Is we take observations or we take information that are given by any department or any company or any provider for the information, and we study the information, analyzing them for order to make decisions for the future. So data analysis is very important. There is something that you insisted on or emphasized on that is very important, and regarding the difference between a sample and the population. Population considers everyone in, let's say, a country, or every part of a group, every single part. So let's say we're taking the population of the United States. It means if we do a population, is literally we take every single human being living in the United States and we ask for their opinions about what they are doing, or not opinions, perhaps their input or their piece of information, their age, their spending, their gender, whatever. If we take sample is literally taking pieces out of those population to give us kind of an estimation, because it's very illogical and it's not really feasible for us to take population into consideration, because it's time consuming and it's money consuming. You cannot really control everyone and put them into one category and analyze them. So it's very important that we understand the difference between parameters, which are the kind of the statistics that we obtain from populations, and the actual statistics that are the information we obtain or the information visualized to us from population. We have parameters, statistics are from samples, okay? And that's the point. Before we start, now I'm going to start with questions and I'm going to elaborate as much as I can into each one. Question number one, what is the format, variables, qualitative and quantitative? There are two types of information given or provided. When I mean information, it means data. There are qualitative and then we have quantitative. Quantitative is something that considers mainly numbers, things that can be countable, and it has two types, continuous and discrete. And I'm going to go further into question two. Then we have the other type, which is qualitative. Qualitative is when we consider other things, is when we study our database and thinking about analyzing things that are qualitative in meaning. We're not studying number, we're not studying age, we're not studying money, we're studying maybe the color of hair that people have, or maybe we study nationalities as we have in our example, or we study things that can be either ordinal or nominal, and that we will go to. Now, what is the format of variables in quality? Okay, so question number one, if we scroll here, I did not count guests because it's not really something that we can count here or something that we can put, so I did not include that in question number one. When it comes to gender, if we, I'm gonna actually combine question one and question two because they're quite important. Question two, what type of, is it continuous, discrete, categorical? When it comes to qualitative data, it can be both nominal and ordinal. What do I mean by ordinal? Ordinal is that we can order it, put it in order. For instance, we can order hotels into several categories depending on how many stars they have. This is the example that you always give us. 1 star, 2 stars, 3 stars, 4 stars, or whatever. When it comes to nominal, it's something that we really cannot put in order, like the gender, nationalities, hair color, eye color, these kind of things that are not really, they cannot be put in order. When it comes to quantitative, I said we have continuous and we have discrete. When it comes to discrete, it's a number. It's one number that doesn't have 0.0035. It's just one discrete number. For instance, age here. And then we have continuous. Continuous is perhaps something that we can have like 0.0. It's not a certain number. It's not one like actual number, not discrete number. Continuous can be the degree of the temperature. Let's say the body temperature is 36.90034. This is a continuous number. As for total spending, because total spending can be 0.0, like you take 2 euros and I get back 1.5 euros. That's what it is. So gender is qualitative nominal because we cannot order it. Nationality is qualitative nominal because we also cannot order it. Quantitative discrete age, because age is 1, 2, 3. We cannot say he is 3 years, 0.2. It's just one discrete number. Quantitative continuous, I said money because money can be point something. Okay? Prepare descriptive statistics for all positive variables using the data analysis tool pack. Explain why you chose those variables and not others. As we have discussed in previous classes, when it comes to the tool pack, which can be found from data, we press data analytics tool pack, and then we go to descriptive statistics. Okay, then we select, that's what I did. I selected the two inputs that are the numbers, including all the numbers. Sometimes you can include the labels, but there is a condition. We include the numbers and then we press OK. I'm not going to press OK. Then of course it's a column, it's not a row, columns. And then if you choose labels as written here, it says labels. If I choose labels here like that, I need to include labels because it doesn't count labels. Then output range, and then I choose summary statistics. You press on summary statistics and confidence level, for instance. And we will talk further into all of these details. Why have I chosen those two? Because this tool pack cannot work with qualitative data. It's numbers. Here we're talking about the central tendency measures. We're talking about variables. We're talking about shapes. These things cannot be actually put into quantitative data. Okay, so it's very important that we differentiate between the things that we can have a descriptive statistics for, which are usually numbers. That's why we choose age and total spending. And for gender, nationality, we cannot, so we just use them. As you can see here, I did not actually read question 4 to 9. That's why I started with question 3, and I put already the categories of each of the statistics. We will go further into more. So prepare that. I showed you how we prepared the descriptive statistics using the analysis tool pack. Explain why you chose those specific values. We said because the tool pack cannot let us choose qualitative data because Excel studies numbers, works with numbers, and we cannot really have a mean or a mood or confidence level for, let's say, nationalities. Okay, so I'm not going to elaborate more on those. I'm going to be writing or including them because I have like a small description of each. I will submit that and you can read it, but because question 4 and question 9 are more important and they can guide me more into like elaborating. Just making sure that we're recording. Okay. Now, create the descriptive statistics of total spending and answer the following question. I have copied and pasted the total spending from the previous slide. Just copy paste. And I took the numbers. Now, which are the central? First of all, we need to find the descriptive statistics. What I did is data analysis, descriptive statistics. You choose the column. I chose those like that. You choose all of them. I don't like to choose the label. Sometimes it confuses me. I remove label. I choose the input range, which I chose to be here. And then you choose summary statistics, confidence level of 95%. This is very important. I'm going to talk about it more. Then we get those numbers, okay? Once we get those numbers, we will be going through each one of them and analyze what do they mean. So I'm going to read the whole question, then I'm going to start answering the questions. Which are the central tendency measures? Central tendency measures are in the one in yellow. Central tendency measures When we talk about descriptive statistics, as you have already mentioned in classes before and videos, it's when we try to describe something. Descriptive statistics is we are describing the observations or the information that we have on hand. We cannot just focus on central tendency and then say it's enough, or focus on variables and say we need to combine all of them and analyze kind of all of them to get a better view or better understanding of the piece of information that we have. Okay? When it comes to central tendency, it covers three areas: the mean, median, and mode, as I have pointed here in yellow: mean, median, and mode. When it comes to variables, it's standard error, standard deviation, sample, and all of those. I don't want to be talking too much. Then when it comes to shape, it's kurtosis and skewness. Okay? Now, what are the central tendency measures? Central tendency measures are measures that we take in account to kind of study three major aspects: the mean, median, and mode. What is mean? What do we mean by mean? And now I'm going to be writing notes, and that's my part you will be grading when I submit. What is, what is mean? Mean is simply the average of the observations. Okay? And I forgot one is here, observations. Okay? It is simply calculated by summing up all the observations from the data given and dividing them by their total number. It's simple. It's an average. So we take all of those observations, we add them together, we sum them up, and then we see how many they are, and then we divide them, which is the count. Okay, count is 30. And then we go to standard. No, I'm going to actually go to median. I'm going to finish with the central tendency, then we understand the rest. Median. What do I mean by median? Median is the middle value. It is an indication to the middle value in position, not value. It's in position, not value. Not value. It's important that we understand it's a position, it's not value. It means that 50% of the data is above the median, and the other 50% is lower than the median. What do I mean by that? Let's give the example of let's stick to the example that we have. Okay, if we look here, we have the median being 1664. If we look in the median here, of course, median, if you want to get the median, we need to be ascending the order. You're putting the information in ascending or descending order in order to find them how it's like lower or higher, because we said 50-50. And the median is just the value. It's a position. It's not actually like the middle. It's the middle class between the upper 50 and the lower 50. But it's just the positioning. It's not the value. It's important that we know that. Mode. We see here we have error. What do we mean by mode, and what is mode? I'm just going to make sure that it's important. Indication and value in the position, not value. It means that 50% of the data is above and the other 50 is lower than the median. Okay? Now, when we talk about mode, what is the mode? Mode refers back to the observation that has repeated more than once in our data given. Okay? And it can have no mode or unimodal, bimodal, or multimodal. Modal. In this case, it is it has no modal, and meaning we have no observation that has repeated in our data given. Okay? I'm gonna elaborate more on that because I think the median is very important to understand, and the mode is also very important. Okay, mode, as I said, we can have no mode, we can have bimodal, unimodal, and multimodal. When we have no mode, it means that all of these observations, we have no one given data that has been repeated again in our data set. Okay, let's say we have a data set from 1 to 10. Okay, if we have no mode, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the observations. Let's say we have unimodal or unimodal. Unimodal would be 1, 2, 3, 3, 1, 2, 3, 3, 4, 5, 6, 7, 8, 9. Okay, so here in our data set, if it's unimodal, it means we have the mode being 3. If it's bimodal, we can have more than that. So it can be 3, 3, then after it's 4, 5, 5. Then in that case, we have two models, which being 3 and 5. Okay, multimodal, 3 or more. We have 3, 3, 4, 5, 5, 6, 7, 7. In that case, we have multimodal. Okay. Now we have studied central tendency and we understood the concept of central tendency. Now we go to variables, which are a bit interesting. Why? We start with standard deviation. Actually, I'm going to go over standard deviation, then I'm going to go back to standard error. Standard deviation refers back to how far are our observations from our mean are. How clustered our information from our mean are, which means it shows the relationship between our observations and data given with our mean, the mode, the average. How clustered, how far. Okay, the bigger it is, the more clustered, or the further it can be. Okay, it's very important that we understand the standard deviation. It is one of the core things because it relies on because we have the variance that also relies on standard deviation, and we have also standard error. So standard deviation is simply it's an indication, shows how far our observations are from our mean. Okay, when it goes to sample variance isn't solely connected to mean, because we get the variance, it's the square of the standard deviation. But how do we get the standard deviation? Is by getting the variance. It's not really connected to the mean, but it's the square of the standard deviation. And we cannot really compare the variance with the standard deviation with the mean, because the variance has a higher amount compared to the mean, because it is up to the power of 2. So it's very different. I'm always referring back to the videos that you showed us, the pumpkins, when you said that we have to put them to the power of 2 because we have some values being minus. If we have minus values, they're going to go with the ones that are positive. So we have zeros instead of having actual numbers adding up and giving us a mean. That's why we use the variance first to get our number, then square root to get the standard deviation. Okay, standard. It is the square of the standard deviation, and it is highly... Oh, that's enough. I think I have elaborated enough talking. Okay, so sample variance, as I mentioned. Then we have the range. What is the range? Is the difference, literally the difference between the minimum and the maximum. What do I mean by minimum, maximum? Minimum is the lowest amount or the lowest value of observation, and the highest is the highest, literally the one with the highest value of the observation. Here we have the maximum being 2156 and the minimum is 1185. If we deduct those two, so this minus this, we get this. That's the range. Minimum, as I just mentioned, maximum, as I just mentioned. Sum is literally taking all of those observations and summing them to get that number. Count is how many do we have, number of those observations. If we can scroll down, it can be shown here. I'm not exactly sure. It should be shown here somewhere. But yeah, if we count them one by one, I mean, it's still from 11 to 40. So if we include them, like if I start counting them, they're going to be 30. When it comes to confidence level, we have chosen 95%. What do I mean by 95%? Confidence level is something that we use in order for us to analyze the information even more. Now, using the confidence level, I need to calculate two things. The upper confidence interval, lower confidence interval. Okay? Upper confidence interval. I'm going to elaborate more. Upper confidence interval is literally the mean plus the confidence level amount. Okay? The lower confidence interval is literally the mean minus the amount that we have from the confidence interval. Now, I like to make the amount smaller so I can talk about them in a simpler manner. Okay, now we have those two amounts, and then we have those. What do we mean by those two? Now, confidence level, we have chosen it to be 95%. How do I interpret that? It means that our true mean, and by true mean I mean the mean of the population, is 95% more likely or 95% accurate to be between the two intervals, between these two values. It means that the true mean, the mean of the population, the one that we have, the actual population, 95% is falling between these two. So I'm going to write it down in an interpretation text here. It means that 95% of our true mean falls between the upper confidence interval, that is 1799, and our lower confidence interval 1593. Okay, so it means that 90% of our true mean being between upper confidence exactly. Now, sometimes it's in the slides also written, we can have 99%, we can have it lower, we can have it higher. I mean, in business, it's possible that we can have it as 95%, it's accurate. But if we're talking about things that are medical or something that requires more accurate data, then we need to refer back to higher percentage, being 99% or even more than 95%. But in our case, because we're dealing with business, it's okay that we have it 95%. And what's most important is that we understand the correlation between these four things: the upper confidence amount, the confidence level, and the mean. Okay? Now, after we analyze those, I still have to talk about the standard error. What is the standard error? Standard error shows how accurate our mean estimations from our true mean. It shows us how accurate. The less the amount, the better it is. The less the amount, it shows the more accurate the information is. Okay? When it comes to shape, I know I might not be writing that down, but I don't want to, because I think I'm talking too much. So if we're talking about the shape, we have the curtis and skewness. What do you mean by curtis and skewness? Curtises, it is simply, it shows the shape of the observation, the shape of the data given, if it's flat or peak. If we have the number being higher than 0, which is in that case, if we look at the curtis, it's below 0. It means it's kind of flat. Okay? If we had higher than 0, it's more peaked. Peaked, it has a rough top peak, literally. It means a peak. So in that case, because we have the amount being in minus, so it's less than 0, so it's flatter. Skewness, it shows us how symmetrical our data is, if it's symmetrical, if it's not symmetrical, and depending on the value as well, we can know to which side it's skewed. In that case, if we look at it, it's higher than 0. If the amount is bigger than 0, it means it's skewed to the right. If the amount is lower than 0, if it's minus, it's going to be skewed to the left. If it's 0, then our mean, median, and mode should be the same, because we're not going to have it. It's going to be symmetrical. Okay? So it's very important that we understand the shape because we can visualize things in a better manner. Okay. So as I said, skewness shows to how symmetrical, not symmetrical. Kurtosis shows how peaked or flat our data set is. Okay. I think I have calculated everything. Calculate the confidence interval, normality, variable measure. Okay. I think we're good. Dispersion, give an example, a definition of each variability, measurements you identify. Yeah, I have covered that. Let's go to question number 10 and 19. As we can see here, I have done quite a lot here because I don't want to waste time on just pressing buttons, but I will elaborate and talk. Prepare a frequency table which includes absolute frequency, relative frequency, cumulative frequency, relative cumulative frequency, and the histogram for variables of total spending. So we are again in total spendings, okay, in order to be able to answer the following question. So I literally copy paste again the total spendings. First thing we do, in order to start finding our frequency and frequency table, cumulative or whatever, we need to find our bins. How do we start finding our bins? We need to calculate minimum and maximum. There are simple formulas. You can simply go one by one and check them, or you can go with a formula that is minimum. You choose all the values and it will calculate as the minimum. Then you choose the maximum and it calculates the maximum. So we get what is the maximum and what is the minimum. After that, we need to establish bins. Bins should be consistent. It means if I start as I'm showing here, 1100, it has to be 1200, then 1300. I cannot go 1100, 1150, then 1200, 1200. Like, it has to be consistent. 100, 100, 100. That's the difference should be between each bin. So I decided to establish those bins starting from 1100, which is lower than this amount, to 2300, which is slightly higher than this amount. Okay, I established my bins. I had nothing here. These were empty. So let's imagine these were empty. What I did is I go to data analytics. You go to histogram. Okay, then input range. Input range is this part. Enter. Then we have the bin range. We have just established our bin range. We make sure that if we want to choose the bin with label or not, this time I'm not choosing the bin, but because it's just written, I pressed there. So there are no labels. Output range, I pressed to have it here, exactly. And then I did chart output because I want to have a histogram that I can demonstrate. Okay. And then we press save and we get those two ranges only. Okay. That's what it shows us. And the bins are, instead of having them as a range, you have them as those values, 100, 1100. And this one, instead of being a range from 1100 to 1200, it was 1200 only. Now, in that case, we need to start building. So we get the frequency, okay? Then I started doing my relative frequency. Relative frequency is simply taking our frequencies. We need to sum first the frequencies. The sum of frequency is simply going, it's just literally the sum of that. You just press that button and you get the sum. And then to find the relative, anything that says relative, it means percentage. So to find the percentage of each of those frequencies to the total, we need to divide this by this, this by this, this by this, depending. So in that case, we can see that all the formulas have been divided the same way. And it's simply like I do one and then I scroll down. I take my mouse and I scroll down. Now, to make sure that we're 100% good or 100% correct, if we want to know, this should be 100. That's why I highlighted it being being yellow, because it shows that we're including all the observations and all the values, because it starts with 0 and it should end with a 0. If there are more values, this should be more if it's not included in a way, or if it's included, should be in total of 100. Then when it comes to cumulative frequency, it's simply, how can I put it in words? Cumulative frequency is the stage that we're in. That's for the first one. If we go to the next stage, it includes to the stage that we're in and the stage below. That's cumulative. The meaning of the word cumulative, it cumulates. So cumulative frequency, we started with the 0, then 1 plus 0, then we have 1, which is this one, plus 1, we have 2. That's the formula. Then if we go 3 plus all of these, which is 1, 1, 0, we have 5. And that's how it goes. And we have just to drag the whole formula down and we get our values. Relative cumulative frequency is simply we take those values that we just calculated and we divide them by the frequency total, as mentioned. Okay, so each amount, it should be shown as, it should be shown how I calculated each one of them. Now, of course, we need to reach 100. Here you can see I have 300s because I have the last observation I had was in the range of 2156, which included in this range, kind of, not more than that, and not less. So after that, I had zeros. So they had 100, but they weren't like 101, 102, because it should end at 100. That's why I stopped. Okay, so referring back to the question, prepare a frequency table, total spending, in order to be able to answer the following questions. So we prepared the relative, cumulative frequency, absolute, all of them. Now, we need to start answering the questions. Now, before we answer the question, I decided to do the pens. We have a histogram that shows the amount. And of course, you've showed us how to change the width and how to have like certain spaces between them and how to make it more visual and more understandable. So solid line, we can have the solid line being in black so we can see it more. And then before I had the amounts being, as I said, the pens, but now I had to change them so it's more visually understandable. So I had to change from 0 to 100, let's say those examples. So I had ranges. These are grouped data. In grouped data, we kind of lose information. I'm going to talk about that more in the upcoming questions. We have two types of data. They are non-grouped or grouped. When we have non-grouped, we can obtain more information. When they are grouped, we kind of lose some information. Okay, so this kind, it's grouped because we don't have the actual amounts in between the 1200 and 1300, but we are including all the amounts in between in one group. So that's a grouped information or grouped data. As you can see, I have changed, so it's arranged. This shows like from 1300 to 1400 and so on. Now, if we go to the questions and check, it says how many people spent between 1,900 and 2,000 euros. So 1,900, 2,000 euros, it's 1. It says between. That's my keyword, between. It did not say below, more. It said between. So if we want to answer, it should be 1. Frequency, 1. So it's 1. One person that spent that much. So question, let's try to start answering. Question 11, we say 1. Now, question 12, in terms of percentage, how many people spent between 1,000? So we're still in the same range, 1,900, we have 3.3%. Relative frequency, we're not talking cumulative, and I will elaborate more in the next questions. So it's 3.3% of the whole thing, okay? Because we're just saying between 1,900 and 2,000, between. We're not saying more or less. In between, we have 1%, that is 3.3% of the whole 100, okay? So this answer should be question number 12 is, how much did we say? 3.3. Or actually, I will do that. Oh, being this amount, if I can do that now. Oh my god, sorry. Actually, I will just do this. Okay, so question 12, I'm gonna figure out the way to visualize the information in a better form. How many people spent? Okay, so we finished question 12. We have question 13. How many people spent less than 1,600 euro included? Now, when we say more, less, we have to look at cumulative because we're including everyone that is below. In this case, we said included less than. So it's less than 1,600. Where is less than 1,600? This is more than 6,000. Then it's this one. We go to frequency, no. We go to relative frequency, no. We go to cumulative. We have 11 people, and their percentage is 73% out of the 100. Okay, so question 13 plus 14 are, we have 11 people, and the percentage was 37%. Percentage. Okay? Oops. Actually, there is no need for this. Percentage. Now we got those. I'm gonna color them more to make it more visual. How many people spent? In terms of percentage, we found how much the percentage was. Now, how many people spent more than 2,000 euros excluded? So 2,000 are not in. So if we look at that, 2,000 excluded. Okay, so it's not here because 2,000 being the higher amount, it's there. So more than 3,000. So we have the total of the spenders being 30. The amount of them are being 30. Now to know how many people spent more than 2,000, we go to the 2,000. Okay, they were 27, and in total we have 30 people. If we take the difference between those two, we get 3, which simply can be looking at from the frequency. So we have 3, okay? 3. Because it's excluded, okay? If we look at it, it has to be 3 because it's excluded. Okay, if it was included, it can be this one as well. So, how many people spent more than 2,000 euros excluded? We said 3. Okay, so question number 15, we say it's 3. Okay, in terms of percentage, how many people spent more than 2,000 euros? Here I had a bit of confusion, miss. I don't know if you want include the 2,000 or exclude spent more than 2,000. If it's included, and we talk about percentage here, relative, if it's included, it should be 20% because we take this one and this one. If it's excluded, it should be 10% only because we're taking more than. So I'm gonna have two answers and I'm gonna explain why. So in my video, I'm telling you if it was included, it should be 20% because we're taking that 2,000 inside. If it's excluded, it should be 10%, only 10%. And we look at relative frequency here. Now, question number 17. Question number 17, how much is the average spending based on the frequency? Average is the mean. And when we talk about the mean, we remember that we have descriptive statistics. We just use the tool pack, easy, simple. But here in that case, we cannot. Why? We have grouped data. How am I gonna use those data to get my data analysis? It's complicated. It doesn't allow me to just press that toolpack, so I have to do it manually. Since we have bins that have ranges, upper class limit, lower class limit, we need to find something called midpoint. What is the midpoint? It's simply the difference between the upper class limit and the lower class limit between brackets divided by 2. And then we get the amount in between. We call it the midpoint. So I calculated the midpoint for each one of the bins that I had. You can see here. So 2,000 plus 2,100 divided by 2, I get 2,050. So we get the midpoints. After calculating the midpoints, we need to find something called frequency midpoint. Now, because we found the middle part, so let's imagine there is a line, thin line between each of those, and this thin line is visualized as those amounts, and this is how we kind of find the middle range. We need to find the frequency of those midpoints, simply taking the midpoint, multiplied by the frequency that we have. All of that we're doing is to get the mean. The mean to those amounts, as we said, they are grouped. When things are grouped, sometimes information can be lost. That's why we had to do midpoint and that we had to do frequency midpoint. So after calculating the frequency midpoint and its simple calculation, we sum up all the amounts. After summing up the whole amount, there is a formula that we have. When we have a grouped information and we have our group bins and we need to find the mean, it's simply the total of frequency midpoints divided by total frequency. Okay, so I calculated the mean having total frequency midpoint divided by frequency mean. Now the amount wasn't like that, the amount was bigger, but because I wanted to be visually represented in an easier way, I decided to put it smaller so it can be seen here. That's question 17. So this is our mean. This is our average. Which are the model class and median classes of the frequency table? Explain how you calculated them. The model class, as we said, model refers back to the quantities that had or have been represented or repeated in our database or data observations more than once. It's easy. We just simply go to frequency and we search for the highest one. Which one was the 6? We had 6 frequencies, so the model class is the highest frequency, so it's between 1600 to 1700. That's our model class. I'm not writing it down because I have my information here a bit not organized, so I'm going to write it down as soon as I finish the video, but I'm explaining how I got the amount. So you look at the frequency, which one is the highest frequency, you get it from 1600, 1700. That's our class model. Then it comes to median. Median, we're finding the class of the median. We're not finding the amount. It's the amount. It's complicated, and it's extra piece of information. If we want to obtain it, it has a huge formula, but you decided to be nice to us and ask us only for the class. How do we find the class? We have a simple formula, which is n, which is the number of frequency, total number of frequency, plus 1 divided by 2. Okay? Now we get an amount. This amount is 15.5. When we get this amount, we need to search in the cumulative frequency. This amount, where does it fall? So in the 0, of course not. 1, no. 3, no. 5, no. 8, no. 11, it's higher, no. 17, yes, because 15.5 is in the class of 17. It's cumulative, so it was part of the 17. Then we go back, we search, and yes, indeed, it was part of the intervals 1600 to 1700. So our median class is in this range, which is the 1600 to 1700. We simply found it by using the formula of n plus 1 between brackets divided by 2. We get this range of, it's kind of part of the cumulative frequency. We search it in the cumulative frequency, which was here in the 17, and while we have the information being obtained like that, we can go back to the bins and find the range where the 15.5 falls in between. Compare and explain why they differ from the central tendency measures in raw data. And I said, in raw data, let's go back to our first example. Here in our raw data, we have all the information. We don't have bins and it's just not grouped. We have raw data that is more it has more information. We have everything, literally. We have ages. We don't have a range between age 10 and age 20, 20 to 30. So we have actual data that has more information. Why it's different? First, I cannot select this in data analytics toolpack because it's not going to calculate it for me, the mean, median, and mode, because it's ranges. It's from 2. It's grouped. So we lose information. And the second thing is that we need to understand that when we have ranges, we kind of need to find the between, which was the midpoint that helped us finding our mean. So the difference is that when we have grouped or non-grouped. In grouped data, like these ones, we need to calculate it manually using the formulas that I presented here. But when we have it non-grouped, so raw data, we go to data analytics toolpack and we use the descriptive statistics and we get our percentages. Because we don't have any ranges, so we don't really have to find any upper class limit, lower class limit. We don't need to find midpoint or those numbers. So I hope I delivered everything that needs to be delivered. I might have spoken too much, but I understand the subject fully. and I want to kind of deliver how much I understand, because as a teacher, I think it's important for you to know that we understand the subject. Just going back to make sure that I have covered everything, and I guess I did. Now what I'm gonna do is I'm gonna shut down the video, make it visually more appealing, and that's it. Thank you very much, Miss. I hope that was enough. Thank you very much and have a nice day.